Hello. In my last video on the biology of stress, I primarily focused on the nervous system, how the brain processes stress. So we did talk about how stress affects the entire body, and there are two systems that are involved here in processing stress. The nervous system, and we talked about it, the central and peripheral nervous system. The peripheral nervous system, they bring in messages from the environment, messages of threat, messages related to stresses, different stresses in the environment. And then that information is processed by our brain. And especially when it comes to stress or any kind of emotional stimulus, it is the limbic system, which is there in this middle part of the brain that plays a critical role. We have already discussed these things. And we also discussed some of the important parts within the limbic system that are critical to the processing of stress. And then, of course, how they impact in processing stress and managing stress. We have discussed all these things. For example, we discussed that amygdala, this small almond-shaped part of the limbic system, that is the part that senses the threat from the stressors. And that's a very critical part. And we will talk about these parts again later, especially when we go into different theories of emotions. But that's for the next lecture. But in this video, I will be focusing on the endocrine system. So we talked about how the nervous system processes stress, but we haven't yet touched upon the hormones, the stress hormones. The stress hormones play a critical role when it comes to both the experience of stress as well as how we then manage stress. But before we delve deeper into these various stress hormones, one thing that you should remember, especially within the hypothalamus or within the limbic system, it is the hypothalamus that is the critical part within the limbic system, because that is the part that sends out the signals responsible for releasing different stress hormones. So hypothalamus is very important here, very critical here. And you would remember that hypothalamus also plays a huge role in our sleep cycle. So that is the reason in this video we will be touching upon both the stress hormones or the different hormones that are associated with stress, and we will also be touching upon the circadian rhythms, which are nothing but the daily sleep cycle that we go through, because they are highly interconnected. So with that introduction, let's dive into the different stress hormones. Actually, before we dive into the specific stress hormones, this is the broad overview, of course. So anytime we have a threat, okay, somebody, some predator chasing us, or any kind of threat, our brain processes this threat, and then the hypothalamus, so amygdala will immediately sense the danger, and then it will send message to hypothalamus, and hypothalamus will then either directly stimulate some of these glands that are responsible for stimulating or releasing stress hormones, or hypothalamus will send signals to different glands that ultimately send signals to other glands to release this various stress hormones. But ultimately what happens is that these stress hormones are the ones that are primarily responsible for the different sensations that we get when we are stressed. So our heart rate increasing, our breathing rate increasing, there being more blood flow to our muscles and the skeletal system or muscles, so that we can fight or flight, or there being higher blood sugar increase, because then that will give us energy to again fight or flight. These things happen primarily because of the stress hormones. So the brain that essentially sends signals to these different glands, endocrine glands, which then secrete the stress hormones, and then we experience stress as we know it. So what are these different glands, and what are the most important stress hormones that we need to understand? So hypothalamus, as I said, is the main organ within the brain that is responsible for all the stress hormones. Okay. So this seems a little complex, but I will simplify it, I will elaborate it. We have a lot of endocrine glands in our body. So there's the pineal gland, the pituitary gland, and the parathyroid, thyroid, thymus, adrenal glands, pancreas, kidney, even the gonadotropic, or the gonads, meaning the sex organs. So ovary in females and testis in male. These are all the various glands that we have within our body. So endocrine system that way is very complex. But in here, we are not going through all the different hormones that are secreted by all these different glands. We are primarily focusing on the hormones that are associated with stress. Okay. So hypothalamus is the part of the limbic system that sends out signal anytime that we are seeing a threat. Okay. And so this is the first hormone that we will talk about, epinephrine. Epinephrine, it is usually known as adrenaline in layman's language. And hypothalamus is here in the brain, right? It sends out signal to the adrenal gland, which is just above the kidney. So that's where it sends out the message. And this message comes through the nervous system. So through nerve fibers, so the message comes right away, very immediately, to the adrenal medulla. So medulla is the middle part of the adrenal gland. Okay. So, and from the middle part of the adrenal gland is epinephrine secreted, and that immediately increases our heart rate and our blood flow, oxygen consumption. All these things happen by epinephrine. But there is another hormone too, norepinephrine. Both these hormones have pretty much the same effect. Norepinephrine has another added effect of increasing our alertness level. We are extremely alert when this happens. So let me actually yes. So let's go through epinephrine first. So we immediately feel stressed. Our heart rate increases immediately. There is a sudden surge of energy when adrenal gland, or the medulla part of the adrenal gland, secretes adrenaline or epinephrine. And you realize why this happens, because we have to deal with the threat immediately. There's an immediate danger. Yeah, let me give you an example. Let's say you're driving, that's a clear road, calm road on the highway, and suddenly somebody cuts you across at a very fast speed, and you literally wake up not in the sense that you are sleeping, but even if you are sleeping, you will wake up with the sudden honking and suddenly somebody cutting off. But there was a sudden danger to your life. So that reaction that you see in your body, your heart rate suddenly pounding and your blood pressure suddenly having skyrocketed, all this is happening because of adrenaline hormone, or other words, the epinephrine hormone. And this happens directly, hypothalamus sending signals to our adrenal glands, which are just above the kidney. And this signaling comes through the nervous system. So nervous system, of course, because those messages are passed through electrical means. So immediately, within fractions of a second, adrenal gland gets the message that, hey, there is this danger. And then the adrenal gland floods the system with the adrenaline hormone, epinephrine hormone. So that's how we get this immediate response. But we have another hormone, norepinephrine, also called as noradrenaline. Okay, that also has pretty much the same effect. It also has this immediate kind of sudden surge of energy, but along with that, it also increases our arousal. So we are suddenly completely alert and awake to the possible danger. And you realize that why it is important, because you have to be completely alert to fight the threat or to flee away from the threat. So you are completely responsive now. Your body is fully responsive. Now, norepinephrine does few other things too. It shifts the blood flow away from skin and more towards the muscles, because that's where your energy is needed. So why two different hormones for the same task of providing the sudden surge of energy to fight or flight from the threat? Why this? Because we need a backup system. Sometimes for some reason, if your adrenaline is not secreted sufficiently, then at least we have this backup system from norepinephrine that will take care of you. So our body is made such that even if one system is not working, at least the other system, the norepinephrine system, will work to help us fight with the threat or flee from the threat. So these two hormones, epinephrine and norepinephrine, these are the two most critical hormones that are responsible for the fight or flight response. And they are secreted by our adrenal glands, specifically from the medulla part of the adrenal gland, which is the middle part of the adrenal gland. Now, but you have been hearing from me about another stress hormone called cortisol, right? So what is cortisol? Now, cortisol is also a stress hormone, but this is a prolonged kind of stress hormone. So this is not this immediate surge in energy. So while the epinephrine and norepinephrine, they get secreted in your body within seconds, cortisol will take minutes, maybe up to 30 minutes. So this is about preparing the body to fight for a longer enough period of time, or to flee from for a fairly long period of time, because you never know whether the threat will last only for a minute or whether it's going to last for half an hour, 1 hour, 2 hours, right? So we also need to have a system that will continue to supply us with energy that is necessary to fight with the threat, or that is necessary to flee from the threat. And that is taken care of by these two hormones. Cortisol is the most important one, but there is aldosterone as well. These are the two hormones that take care of it. Now this takes time. These hormones take time to secrete. Now why do they take time? Because what happened here, hypothalamus directly sent message to adrenal medulla to release epinephrine and not norepinephrine. This message came through the autonomic nervous system, but that's not what happens in case of cortisol and aldosterone. Hypothalamus actually sends message to the pituitary gland. Pituitary gland, you can see, is present pretty close to hypothalamus in the brain region. Now this message is not again happening through the nervous system. Rather, hypothalamus releases a hormone called CRH, corticotropin releasing hormone. That hormone, when it reaches the pituitary gland, it signals the pituitary gland to secrete ACTH, which is adrenocorticotropin hormone. And from pituitary gland, through the circulatory system, when the ACTH hormone reaches the adrenal glands, then adrenal gland starts releasing cortisol and aldosterone. So it's a longer process. So this will take 15 minutes, 30 minutes for the system to be flooded with cortisol and aldosterone. So while epinephrine and norepinephrine, they provide this immediate surge of energy to fight or flight, cortisol and aldosterone, they are the hormones that are responsible for sustaining that energy that would be needed to fight or flee for a longer period of time. So how does cortisol work? What cortisol does is it increases the amount of glucose in the bloodstream. So that way you will have more energy to sustain that fight or sustain that flight. Okay, and it does few other things also. It literally decreases lymphocytes that are secreted by thymus and lymph nodes. In other words, your lymphatic system that is responsible for your immunity, immunity from any kind of diseases, from infections. Now, those things are not as critical, especially when there is a more imminent danger that you are fighting against or that you are trying to flee from. So, cortisol will also reduce the activity levels in your immune system. And I had already talked about it, that how the hippocampus region has a lot of these corticotropic receptors, these cortisol receptors. So if we have too much of cortisol in the system for too long period of time, over a period of time, the hippocampus part of the brain gets damaged. So again, you will remember this from, yes, so hippocampus, the part that is responsible for processing our memory from short-term memory to long-term memory. And I had talked about it. It has a lot of these glucocorticoid receptors. So if you are having long-term stress, and there is always a lot of cortisol in your system, over a period of time, your hippocampus start getting damaged. So you will then have you will start having memory problems and motivational issues, depression, and those kinds of issues. So that's okay. Now, what does aldosterone do? So while cortisol is primarily responsible for increasing your glucose levels in the body so that you have energy, aldosterone, it takes care of the sodium levels in your body. Okay, because sodium has a critical role. Wherever there is more sodium, there will be more water retention happening, and consequently, indirectly, it is related to there being more blood volume. So you will have greater amount of blood volume there, and that is necessary because, and again, with our oxygenation happens through blood, and through blood only we will be getting that complete oxygenation and energy being supplied to the different parts of the body, to the different muscles. So our heart would start pumping also faster. So the effect that aldosterone has, so aldosterone is also a stress hormone, right? It increases blood volume by sodium retention, and it increases our blood pressure. So that's I have talked about it here. So cortisol, it takes longer time because it's multi-step process. Amygdala senses the danger, sends signal to hypothalamus, but in case of epinephrine and norepinephrine, hypothalamus directly sends signals to the adrenal glands to release epinephrine and norepinephrine. But in here, hypothalamus releases CRH. That once it reaches pituitary gland, it releases ACTH. Once this hormone reaches the adrenal cortex, then is cortisol release. So it takes much longer time. Okay. So cortisol again is important because it helps sustain our fight for whatever it is that we are fighting. But it suppresses the immune system. It increases our blood sugar, blood pressure. Again, it decreases our libido. Sex need, those things are not important when you are fighting for any kind of threat. So prolonged exposure leads to you starting to lose your sex drive, obesity, acne, and all kinds of problems is what you experience when you have too much of cortisol in your body for prolonged periods of time. Now, there is another set of hormones, the thyroxine and triiodothyronine, for short T3, T4. They tend to get converted into each other as well. But these hormones typically don't get discussed in context of stress hormones, but they also are impacted by stress, because these two hormones, T3 and T4, thyroxines, different variants, they increase our basal metabolic rate. They increase free fatty acids into the system, so there will be more free fatty acids. So that's how over a period of time you start gaining weight. There is a rise in heart rate, rise in blood pressure. So this mechanism is also very slow. So hypothalamus sends TRH to the pituitary gland, which then sends TSH and ADH, and then thyroid starts secreting this hormone. So this is again very long process, similar to what you see for cortisol and aldosterone. But the key hormones when it comes to stress are epinephrine, norepinephrine, cortisol, and aldosterone. These are the four key hormones that you should not forget about, because they have important implications for the experience of stress. And especially when it comes to cortisol, because a lot of our modern day stress is something that we have over a long period of time. It is not some immediate threat that we have to face, and then if we survive, then we are back to being normal. That's not the case. When we are at our jobs, when we are even at school, or if we have we are in some difficult relationships, we have these stresses continuing for really long periods of time. And that's why cortisol becomes one of the main hormones that is of importance, that we need to manage well. And I have already talked about this. When there is too much of cortisol in the body, we see what is called hypocortisolism. So there is Cushing syndrome specifically happens when there is damage to certain these adrenal cortex, and but but for that matter, so you may not have classic Cushing syndrome symptoms, but even if you have the have prolonged stress in your body, if you have chronic stress, if you are suffering from chronic stress, you will start developing symptoms similar to Cushing syndrome. So stress-induced hypercortisolism or stress-induced cortisol, too much of cortisol in your body for a prolonged period of time, is typically not described as Cushing syndrome, but you start developing symptoms similar, if not to the kind of extremes that you see in case of Cushing syndrome. So you start becoming obese, you start developing blood pressure, blood sugar, diabetes, all these problems, because ultimately you are having too much of cortisol in your body for too long a period. So and you start developing weaker immunity. You easily get sick. Now these things were important for your survival, but not so much in the long-term health perspective if you have too much of cortisol always in your body. So you start developing hypertension. If there is too much of sugar in your body, that's what cortisol does. It infuses too much of sugar or glucose into the bloodstream. But then it leads to the insulin is the hormone that regulates glucose. It reduces glucose from the bloodstream. But insulin ultimately gets tired. Pancreas get tired. They are not enough. They are not being able to secrete enough insulin to manage those blood sugars. So over a period of time, then you start developing type 2 diabetes. Okay, and as I've already mentioned, your libido decreases and you become obese. All these problems start happening. So it is important then that you manage your stress really well. So we have already talked about hypercortisolism, that is caused by stress. There is also something called hypocortisolism. This is not relevant to stress because it primarily happens if your adrenal glands are damaged, so they are not being able to secrete enough of this cortisol. Adrenal cortex part of so adrenal medulla is the middle part of the adrenal gland that secretes the epinephrine and norepinephrine. And adrenal cortex, remember, like the brain's cortex, similarly adrenal cortex is also the outside part of the adrenal glands. They secrete cortisol, and when the adrenal cortex is damaged, then it is not being able to secrete enough of cortisol. So that symptom is called hypocortisolism, specifically Addison's disease. They have their own set of symptoms, but we don't necessarily have to worry about it because that is not primarily associated with the experience of stress. So in the short term, this is the summary. Cortisol plays a important role in our survival. They suppress our immune system because that's not where the energy resources are needed. Energy resources are needed to fight. So our blood sugar increases to fight. Serotonin is an important happiness hormone that gets decreased because of too much of cortisol in the system. We will talk about some of these happiness hormones later on. Cortisol has this another important effect of decreasing sensitivity to pain, especially when you are fighting. You will get injured. There is a possibility that you will get injured. So cortisol decreases that. But over the long term, so all these are short-term effects of cortisol. But over the long term, they weaken the immune system. So immune system, you start developing heart disease. You start developing hypertension. There is too much of blood sugar in the body, which is nothing but type 2 diabetes. You start developing digestive problems. You start developing anxiety, headaches. So all these issues start coming up when cortisol is there in the system for too long a period. Now, this may give the impression that cortisol is all bad. Well, it is bad. It is good only in the short term of dealing with stress. But when we have too much of cortisol in the body over a long period of time, that is bad for our health, and that is true. But you also need to know that even when we are not stressed, cortisol gets released in our body. In fact, do you know the time of the day when we have the maximum amount of cortisol in our system? That is immediately after you wake up. So cortisol is the hormone that is it peaks as you come close to waking up, and that lasts for a couple of hours. So let's say you wake up around 6 a.m. So around 3 a.m. your cortisol levels will start rising, okay, and it peaks around the time that you wake up, and it stays within you for another hour or two. So cortisol is also an important hormone that is associated with our circadian rhythm. But why is this important? Because another thing that happens is, if we are stressed too much, our sleep cycle gets disrupted, which is what I was referring to before. And one of the reasons our capacity to deal with stress decreases is also because we have too much of cortisol in the body. And if we have too much of cortisol in the body, let's say during the evening time or during night time, then we will not be able to sleep, right? Cortisol helps us wake up. Actually, I must also mention this. Cortisol levels rise in our body as we start getting ready to wake up, primarily because it helps prepare our body to deal with the day-to-day stress that comes in our life. So it's a you could also call this a waking up hormone. Now, if you have too much of stress during the evening times or late into the day, then it will keep you awake. It will prevent you from falling asleep, right? So, or rather, this is the evening time. So this is where you will be not be able to sleep. So what the hormone that works in antagonism with cortisol is melatonin. Melatonin actually should be high in the evening, because that would actually help you fall asleep. Let's see, eraser. So this is the cortisol levels. In fact, melatonin levels will just follow the opposite pattern. Okay. So this is kind of a rough diagram. So as your body is getting ready to go to sleep, your melatonin levels will start rising. So in the evening, your melatonin levels will start rising. And melatonin actually helps you fall asleep. In fact, many people who suffer from sleep disorders, sometimes then they get prescribed melatonin. It helps them fall asleep. Okay. And cortisol keeps you awake. And you understand why it keeps you awake, because it's necessary to deal with stressors, to deal with so that you can fight or flee from any kind of danger. Of course, it's not fight or flight in the immediate sense. That in that case, it is epinephrine and norepinephrine that is responsible. But for whatever stressors that you have, you need to be awake to deal with those stressors. That's why cortisol is responsible for keeping you awake. So anyway, this is really interesting. Now, what do we do though? If cortisol helps us stay awake, why then do many of us feel the need to drink coffee in the morning? Why shouldn't cortisol keep us awake? And that is because we have messed up our circadian rhythm. So in fact, it is a bad idea to drink coffee immediately after you wake up, because it actually leads to you messing up with your cortisol system. So it is a bad idea to drink coffee. What is recommended then, if you go through the scientific literature, don't drink coffee right after you wake up, because your cortisol is already high there. It is already keeping you in this awake state. Now, you should ideally drink coffee maybe 2 or 3 hours after you wake up. So maybe later into the morning, if you, let's say, wake up early in the morning, later into the morning, you can drink coffee. Or maybe around noon. Those are the times that will be good for having a cup of coffee and getting re-energized to deal with the challenges of the day. Because at that point of time, you realize your cortisol levels are already going down. So you are starting to feel a little sleepy. So that's the time a coffee would actually help. But when you drink coffee immediately after waking up, that actually messes up with your system. But if you have to drink coffee, actually, let me, I had something. Well, I'll talk about it later, probably. Okay, yeah, I'll talk about it later. So right now we are talking about the sleep cycle, right? So it is interesting because 2017 Nobel Prize winners in medicine were these three scientists who got the Nobel Prize primarily because of their work on the circadian rhythm. Now, their work was on fruit flies, so they had modified certain genes in the fruit flies and how then that impacted the circadian rhythm of these fruit flies. That's what they had worked on. But it turns out that it's not just human beings who have the circadian rhythm, but animals, plants, insects, every living creature have these circadian rhythms. So the term circadian comes from circa means about or around, and diem is day. So it follows the sun's cycle. So per day. So when you get per diem, so that is the amount of what money you get per day, right? And when you're traveling. So diem means day, but here we are talking about a day. So because cycle takes about a day. So 24 hours, 25 hours or whatever, depending on the season, of course, but approximately 24 hours or full day is the entire cycle. And it's not just the human beings, but all animals, plants follow this rhythm. So it is essentially influenced by light, sun. So when we wake up, let's say, when the sun rises and you wake up, as I have already mentioned, your melatonin levels drop. So instead, your cortisol levels go up. Cortisol levels will go up, but your melatonin levels will go down because they work in opposite direction. So through light, through different mechanisms, it reaches the hypothalamus and the body realizes that, hey, it's time to wake up. So melatonin secretion decreases and cortisol levels increase. And your testosterone levels also start increasing a little later in the day. So you are highly alert. But as the day comes closer to an end, about, let's say you go to bed around 9, 10, 11, something. Then later in the evening, melatonin increases and cortisol levels decrease. And these hormones, they help you actually, these hormones, they actually help you have a good night's sleep. Melatonin, it helps you have a good night's sleep. So it is important that your sleep cycle is managed well if you want to live a healthy life, and not just that, if you want to be able to deal with stressors better. Because melatonin, I was mentioning that cortisol and melatonin, they work in opposite directions. Melatonin actually has a lot of anti-stress properties. It helps you deal with stress. In fact, you won't age as quickly if you are having proper balanced melatonin system in your body. Okay. So it has anti-aging effects also. Melatonin is responsible for the release of another hormone that is secreted in the brain called GABA, or gamma aminobutyric acid. Now, GABA, we can talk about it later, especially in context of the happiness hormones, but that has a very calming effect. It reduces anxiety. So you can imagine then how important it is to balance these hormones of cortisol and melatonin. And you don't want to mess up your sleep cycle. Sometimes it is just impossible. If we are doing some traveling across the globe, then of course things will get messed up. But as far as possible, if we may be working night shift, again, then our sleep cycle will be disrupted. But as much as possible, if it is within our power to have a normal cycle where we wake up around sunrise, we get sufficient amount of exposure to sun, and then we stay active, and then we go to bed as later into the evening. So that will help you deal with stress much better, primarily because melatonin has these anti-stress effects, and it is also secretes GABA, which has this calming and anti-anxiety properties. So if you suffer from anxiety issues, I had talked about one of the drugs that is given for anxiety is benzodiazepines. I think I gave you example of how Jordan Peterson, one of these famous psychologists, almost went to his deathbed because of the the side effects of that medication. So, of course, if that is what is needed, your doctor may prescribe it. But a much better option, much less risky option would be to, let's say, prescribe you with melatonin. That is, that will have little similar kind of effect at a relatively milder level. So in any case, this is what we need to understand about the circadian rhythm. And another hormone that is associated with melatonin is serotonin. Serotonin is you could call this a happiness hormone too. That helps with the production of melatonin. So if you aren't very happy in your life, for example, that will also reduce the amount of melatonin that your body secretes, which then will prevent you from falling asleep. So these are all very interconnected systems. So, well, before I go there, so how can you manage your circadian rhythm better? Well, the key thing, what I have already mentioned, don't drink coffee right after you wake up. If you have to drink coffee because of being addicted to it, or take L-theanine along with it. You actually get L-theanine in form of capsules, and it's a supplement, so you can buy it over the counter. But L-theanine is a compound that you find in green tea. So instead of drinking coffee, a good option would be to drink tea or green tea when you wake up, because that also has caffeine, but it has caffeine at a much lower level than what you would get in coffee. Plus, along with caffeine, tea has L-theanine, which has a calming response to the body. Okay, so it keeps you alert, but in a calming fashion. Plus, it has another very good effect of increasing dopamine levels in the brain, which will then increase your motivation to work on different things that you need to work on. So if you have to drink coffee early in the morning, better to take it with L-theanine. Even better would be to just have green tea if you are in the habit of drinking something warm when you wake up. So that's one thing that you could do. That way you're not messing up your sleep cycle. Another thing that could be done is, especially in the night time, because this is related to light, right? But these days we get exposure to a lot of artificial lighting. So that then prevents the body to secrete melatonin, and that also then leads us to not going to bed on time, or we watching television, or being addicted to our cell phones, or whatever, computers. We get a lot of exposure to these lights, and especially the blue spectrum of the light. That is the part that harms us the most. That's the part that disrupts our cycle the most. But again, you realize it is not just the blue light, but also when we are playing some game or watching some television, our brain is excited. So then we don't fall asleep sooner. So some of the things to do would be to not get exposed to any kind of bright lights, especially from these gadgets, at least 2 or 3 hours before you go to bed. Now that may not seem like a practical suggestion, especially given how dependent or addicted we are to these devices. But in that case, at least another option would be to wear those blue light preventing glasses that have this red tint, so they reduce the exposure that you get to blue light. That is not a foolproof method, but because your brain is still stimulated from all these exciting games or shows that you're watching or playing, but at least the light part gets taken care of to a certain extent, and then you will have a better quality sleep, and then you will be much better equipped to deal with the stresses of your life during the day, and you will also have a good quality sleep, which is what I will talk about next. Many people think that they are night owls, so they are not the morning lark kind of person. They are not the morning person. They tend to it is their normal body style to stay awake until 2 or 3 in the morning and wake up later in the morning. So it turns out, though, majority, from a natural perspective, majority of people are actually morning people. It's only a very small percentage of the population that are really night owls. But the majority, and this goes to like higher 90% people, by default are actually morning person. Now, of course, their daily habits tell differently. And that is because essentially we have messed up our routine with these bad habits of exposure to light, or maybe our jobs prevent us from again going to bed on time because we may be working later into the night or whatever. But by default though, we all tend to follow the circadian rhythm, okay, like animals, like plants. And it turns out people who go to bed early and wake up early, they have a much lower incidence of schizophrenia, depression. Now you could say these are all correlations, and correlations are not causation, but it turns out they affect each other. So one way to manage your depression, if you are a depressive person, let's say, or if you have been suffering from depression, would be to manage your sleep cycle, because of these different stress hormones and melatonin, how they interplay with each other. Now, a few more things, especially in context of the sleep cycle. Our typical sleep cycle, we go through, let's say we sleep for 7 hours, 8 hours, whatever. Within those 8 hours, we go through several cycles of sleep. So depending on how we classify, we could say there are 4 or 5 stages of sleep. But broadly classified, we have 2 major stages of sleep. From stage 1 to stage 4 are the non-REM stages. Okay, so non-REM, REM refers to rapid eye movement. That is the stage of sleep that is associated with dreaming. So that actually is the stage that you go into before you wake up. That's also the reason why we tend to remember our dreams, because that's the last part of the cycle, our sleep cycle. And all the other stages, there is no rapid eye movement that is happening when we are sleeping. That is the reason they are broadly, they could be called non-REM stages. But each stage is actually distinct from the others because they have different, if we put electrodes onto your brain while you're sleeping, they follow different wave patterns and they have their different functions. But the important thing, the stage 1, stage 2, they are relatively lighter stages of sleep. And stage 3, stage 4, especially stage 4, these are much deeper stages of sleep. And another thing that gets messed up when we don't manage our sleep cycle properly, especially with improper exposure to light or staying awake, our stage 4, the deep sleep stage, reduces substantially. But this is a really important stage because our body repair happens then. So our growth hormone gets released there. So if you may be really working hard with respect to building up your body, but if you don't manage your sleep, then actually you will not be able to do that, because the repair of the muscular damage and all those things will not be happening optimally if you are not getting enough of these deep sleep stage in your sleep. So you may be actually sleeping for 8 hours, but if you have very small amount of deep sleep that you're getting in terms of overall percentage, then you will not be benefiting from those 8 hours of sleep or 9 hours of sleep. So as I was mentioning, each of these stages, they have a different wave pattern. You can see, so theta waves, delta waves and all, but we won't go into those complications because they're not as critical to understanding the effect of stress and managing stress. But these are distinct stages. That's what you need to know. And another important thing to understand is that these cycles are not uniform cycles. So within the night, we may have, let's say, 3 or 4 of these cycles. So during the initial stages of sleep, we will have our body will spend more time in the deep sleep stage. But as in the later part of the sleep, we will not be going so much into the deep sleep. We will be spending more into the light phases of sleeping, especially the REM stage. Now, the rapid eye movement stage, that is also important. That has also benefits. Now, so both the rapid eye movement stage as well as the deep sleep stage, both have their importance. So it is important that we go through this entire sleep cycle properly in order for us to work optimally. Now, let's come to stress in the workplace. This graph tells you how a large percentage of people do work night shift. So 26%, let's say about in 26, 27, close to 30% in the United States, close to 20% in UK, a little less in Germany and France, but in some of these European countries, but you see a high percentage of people working night shift. And you can imagine their sleep cycle gets disrupted completely. But there are certain professions where you just can't avoid night shifts, like if you are a healthcare provider, emergency workers, paramedics, if you work in business process outsourcing companies like call centers, especially if you are working from India and you have customers in America. Because of the time difference, these call center employees in India, they work in night shifts, right, to be able to deal with the customer complaints during the day in America. So those employees, people who are working like pilots and flight attendants, logistics, hospitality, nurses, doctors, military personnel, and so on and so forth. Many professions, you just can't avoid night shift work. So that is a tragedy, though. It is essential, but it is tragedy from your body perspective. It does start taking a toll on your body over a period of time. You start developing these problems over a period of time. May not be immediately, but you start developing these problems, different kinds of endocrine disorders, cardiovascular problems, depression, type 2 diabetes. So you start having all these problems, headache, fatigue, cancer, even cancer. So different studies show all these different types of effect. Your metabolism essentially gets disrupted when you are forced to stay awake. I have already mentioned your growth hormone production decreases. So the downward arrow I'm showing as decreases. So your body doesn't recover properly. And this is, I've already talked about melatonin, right? So melatonin sufficient, you don't have sufficient melatonin in your body, that leads to problem. But we need to talk about these two other hormones. Ghrelin. Ghrelin is the hormone that makes you hungry. Okay, it stimulates your appetite. And it turns out when your sleep cycle is disrupted, you tend to eat more. So when you eat more, then that also leads to you getting obese or overweight over a period of time. And again, developing all kinds of symptoms associated with it. So because ghrelin, the hormone that is released by your stomach, oversecretion of that happens. So you are constantly feeling hungry, even during the day. Okay. And the opposite hormone, which is leptin. Leptin is the hormone that is released by your fat cells. And this hormone, they suppress your appetite. They make you feel satiated. Okay. They make you feel not hungry. And what we see when your sleep cycle gets disrupted is that the sufficient amount of leptin is not secreted, which then again makes you want to eat even more. So you can see how this becomes a vicious cycle and it impacts your health. Now, we can talk about day shift. Night shift are those shifts that where you're permanently working in the night and you have to get your rest or sleep during the day. But the worst is rotating shift. So maybe a couple of weeks you work in day shifts, then a couple more weeks in night shift, and then that switches again. So that is what I'm saying is the rotating shift. So rotating shift is the worst for your body because your body never gets an opportunity to adjust to any proper rhythm. If you are always working in night shift, well, that can be a little bit problematic, or that will be problematic compared to the day shift people. Okay, but if you take certain precautions, let's say you cover your room, you make it really dark, and you get adequate sleep in during the day, you will still be able to manage it. But rotating shift, that is the worst for your body, and that takes a heavy toll on your body. So as much as possible, if it is within your power, try to choose professions where you don't have as much of rotating shift, or at least there is a minimal amount of such night shift or rotating shift. Ideally, day shift will work the best. A couple more things that I would like to touch upon. So this is research by Sachidananda Panda and his colleagues. In one of his presentations, he talks about his studies on mice. So in that study, he gives standard mice, is his mice two different diets, healthy diet and high fat diet. And of course, the group of mice that were getting unhealthy diet, they over a period of time got obese and diabetic. So this is nothing surprising. This is, if you're getting healthy diet, whatever would be the healthy diet for mice, I don't know. Maybe it does involve vegetables. I don't know. We have to check. But their healthy diet versus unhealthy diet. The unhealthy diet mice, they got obese and diabetic, and all they started developing problems: insulin resistance, blood sugar, cholesterol, everything. But he expanded that study to something else. For those mice that were being given unhealthy diet, he then divided that group into two categories. Okay. One group of mice were given food. They could eat any time during the day. Okay. So they ate during the night time as well. Whereas another group of mice, even if they were having unhealthy diet, they were trained to eat only during the day. And it turns out that when you are eating during the day and you are not eating late into the night, that does have an impact on your health as well. So the mice that was eating during the night, it did become obese. Even if these mice were all eating unhealthy food, but still the body fat of the mice that were eating only during the day and not during the night was 70% lower, and overall body weight was 28% lower. And they were, by the way, they were eating the equal amount. So the amount of food that they were eating was the same. That's how they control when you're doing an experiment. But in one case, you could eat any time that you wanted to. So you were also eating during night. But in another case, you were restricting the eating window to eating only during the day. So it turns out that your circadian rhythm is associated not only with the light, but also during your also related to your eating time. Now think about your millions of years ago or thousands of years. We gathered food and ate during the day, or maybe early in the evening. We were not eating late into the night. So that's how our bodies are made. When we mess up our eating habits too, then our overall circadian rhythm gets messed up, and we then develop all these negative symptoms that we see with respect to disrupted sleep cycles. So another way to manage your sleep cycle, apart from managing light, would be to fix your eating habits. Do not eat too late into the evening. Preferably, early in the evening is when you eat, or maybe even before sunset, if you can manage that. So that will also help you fix your circadian rhythm. And by the way, in his later studies, he has repeated this study in human beings, and we tend to see the same kind of data pattern there. So now, this is, I think, where I will be ending, because one last thing, how to take naps. Actually, I do have some more slides. I already told you that the entire sleep cycle takes about 90 minutes. So how long should be your naps? Any guesses? One way to nap would be to only take naps that are 20 to 30 minutes long. So taking nap, it turns out to be a good practice during the day, if you can afford it. Sometimes your jobs prevent you from taking naps, but if you can afford, that can actually keep you energized for a few more hours. But do not take 2 hours nap or 3 hours nap. That will then again disrupt your sleep during the night, right? So the best way to take naps is only very short naps, definitely not longer than 30 minutes, maybe 20 to 30 minutes. Why? Because your body would not have gone into the deeper stages of sleep by that time. So a 45-minute or 1 hour nap is actually going to be less effective than a 20 or 30-minute nap, because when you wake up after 1 hour, you will be in this deep stage of the sleep, in stage 4 part of the sleep. So you will actually wake up very groggy. You had set the alarm for 1 hour and you wake up very groggy because your body was not ready to wake up then. So either take a 20 to 30-minute nap, or take a nap that is approximately 90 minutes, because the entire cycle takes approximately 90 minutes, right? So by then if your body has had entire like 1.5 hours, so you will probably be somewhere in the REM stage when your alarm bell goes off, and then you will wake up rested. But if you wake up during stage 3 or stage 4, then you will wake up not rested, and you will wake up groggy, and you will not get the optimal benefits of taking a nap. So yeah, this is the part that is going to be the last part of my presentation. So we have talked about circadian rhythm. Now there is something in newer research that we now know, which are called ultradian rhythms. So not only do we go through these different parts of sleep cycle every night, but our body follows a similar kind of pattern, if not the exact same forms of waves, but but we see certain cycles during our waking hours as well, and that is what is referred to as ultradian rhythms. So these ultradian rhythms, essentially we get stages of like high energy, and then we go into stages of low energy, and then again our energy levels go up, and again our energy levels take a dip. So we go through these cycles, and approximately 90 minutes of alertness, you will be staying highly alert, and then about 20 minutes of low energy. So during the day, this again gives you some ideas about how to manage your sleep cycle. Sometimes, let's say around 12 o'clock, or actually 2 p.m. early afternoon, that's one of the times that we feel really low. And what do we often do? We reach for some kind of stimulant. It could be coffee or some other stimulant. But you realize this could be happening. The time that you're feeling low is only because you are at that lower level of that cycle. If you wait out for 20 minutes, you will again be starting to feel energetic to deal with the work that you need to do. Okay, so a lot of time management can be done to increase your productivity. Especially, let's say, if you're writing, like what I do as part of my profession, where you have to stay alert and to be able to produce good quality work. I can do that when I am in these high performance stages of the ultradian rhythms during these 90-minute cycles, not when I am in this low stages, which is the healing stage. The way we had those cycles during sleep, deep sleep was the stage where our body was healing. Same thing is happening also during the day, although at a much milder level. So we are not necessarily going into deep sleep, but our energy levels go down because our energy levels are getting focused more on rest and repair kind of stuff, right? So those are the times when our energy levels take a dip. But what do we often do? We force ourselves to stay alert, throughout at this higher level, let's say at this higher level, by taking stimulants or whatever. So that again messes up our system. Now, what you could do probably is maybe take a short walk, and that can wake you up if you are feeling low energy levels during the day. Again, by the way, these are some suggestions that may not be feasible for you to incorporate in your life, especially if you are working at some place. You may not have the option of taking a walk. But if you have those options, then those are some of the better options as opposed to relying primarily on stimulants. Okay, so that will help you manage your stress much better, and you will be much more productive during the day, and you will not get as much of those ill effects of stress that happens to you when you are staying stressed in the long term. So with that, I will end my video here.